Hello, and welcome to Group Nine's presentation of Band in a Box. Today we have David Boggs, Cameron Palomarain, Ariel Tyler Van Dam, and Anthony Kitzmiller presenting 4 different instruments for you. Enjoy.
Proposal content. It's going to have our problem definition, project requirements, design concepts, instrument descriptions, final instrument design, summary, and followed by references. All updated. Problem definition statement: create a group of instruments that are small enough for easy transport and create required acoustics. Each member of the team is to design and create one of 4 instruments, 1 wind, 1 string, 1 percussion, that can each accurately play at least one part of a song. Requirements and constraints: must be less than $15, fit in 2 cubic foot box, no more than 10 foot of pipe can be used combined, same with a 6-foot piano wire. A flat fee of $1 will be added to each instrument for aesthetics, and of course it needs to create the required acoustics. Design criteria. Okay, by weight, we found the most important to be the correct range and frequency at 35%, followed by size and budget, each at 20%, constraints at 15%, and aesthetics at 10%. Now we're moving on to the instruments. This is the PVC flute, the initial mock-up of it all, with the calculations at the bottom left-hand corner. This would be the design we came up with, our initial design, and this is what we ended up with. PVC flute, we had to extend it from 12 inches to 15 inches. It was too high pitch. It does create sound. However, I am no Bach or Beethoven, so I'm going to do my best to make it work. As you can see, I was better at it. You can make better sound, but it does operate. It is cheap to construct, and it's generally pretty lightweight. And of course, it's small and easy and pretty compact. The total budget for is $4.10. It makes it relatively cheap. And we will be moving on to our next instrument. Thank you.
Alright, thanks for that, David. We're going to continue on with my instrument next. It's the dulcimer style hammered string box, and you can see that the string length is related to the tension of the string, and the fundamental frequencies listed here are just to demonstrate some of the notes that can be played by this instrument. On the next slide, there is a photograph of the final product, and this is a very small and easily carried instrument. It's about a foot on a side. Striking the strings creates a standing wave that is related to how we've tensioned the wire, and each string's tension is adjustable, which you can see in this short clip here. Some changes and challenges with the project were that additional wood had to be added to each side to be able to make room for the string mounts, and also material acquisition was an issue. We tried to source products from several stores in the area and from online, and it took about a week and a half to gather all of the materials for the final product. Also, which type of wire to select was an issue. We settled on a soft brass wire. And finally, the budget and materials are represented here on the last slide in my portion. The total cost ended up at about $6. And now we're going to hear from Cameron. Thank you.
The next instrument we decided to do was the pan flute. The way the pan flute works is you blow into the top of each tube. Each tube is a different length. The longer tubes provide a deeper tone, while the shorter ones are more higher pitch. The frequency of the pan flute is found by the length of the pipe in centimeters times the frequency. So for our design sketch, the dimensions are 3/4 of an inch inner tube diameter, 6 inches wide and 9 inches tall. Materials that we will need is a PVC pipe, tape, spray paint, and the estimated cost of all that combined is $8. The size is going to be less than 1 cubic foot. So with our final design, changes that were made was we went from 3/4 inch diameter to 1 inch diameter PVC for a deeper tone. Instead of using tape, I ended up using PVC glue. It was a more stronger and more rigid option. So our overall budget, PVC was $1.50, paint was $1, and PVC glue was $3.33. Total spent was $5.85, and here is our final project. Instead of going with the just under 1 cubic feet, we ended up going just under 2 cubic feet, so it still meets the requirements. And it does make noise. I'm not very good at it, but I'll give it a shot. Now to our next instrument.
Just doing a little bit of extra tuning here. As you can see, I'm presenting to you the Kanjo. It's a string instrument. You can play mid, low to mid-high ranges. It works by vibrating the string, passing the sound wave through a chamber. This is a can chamber. It's mounted to a 1x4 piece of wood, and it's using guitar strings in order to play the music here. As you can see from the sketch and the cost estimate, I used a popcorn can tin because it made such a good sound. Originally I planned on using a smaller tin can, but it just didn't work very well. The guitar strings are fairly cheap. I got mine off of Amazon for $1.23 each. The 1x4 piece of hardwood I bought at Lowe's for $1.92. And the hardware itself, I'm using 7 bolt screws and different nuts, and they were fairly cheap, especially when you buy them separated, coming out to approximately $3.50 for a total of all the nuts and bolts, giving me a total of $12.88 for the instrument. The instrument falls within the 2x2 square size limit that it needs to be. And here we go. We'll play a little bit of the sounds from the guitar here. Kanjo. And by pressing on some of the chords, I can make different frequencies by increasing the tension on the strings. So it does fairly good job. And there we go. That's the Kanjo. Thank you.
In this project, each group member had to build and design their own instrument that hit a certain frequency. Each instrument also had to stay under a $15 budget. This budget required us to think outside the box with our designs while still making our instruments functional. The instrument could be no larger than 2 cubic feet for transportation purposes. We all had to do research on our instruments so we can come up with a functional drawing that we can build off of. Overall, this project challenged us to use many different aspects of the engineering design process and provided a better understanding on how the process truly works.